In questions 1 through 8, we're going to look at the graphs of rational functions, hopefully making a connection between the equation and where the asymptotes and intercepts are located. So for questions 1 and 2, I primarily want to focus on the asymptotes, so the horizontal and vertical asymptotes of this graph. All right, so on this graph I have 1 over x, which we discussed in class, and the blue graph is 1 over x plus 3. By using transformations, there's no surprise that we're going to go up 3 places. So if this is the case, the horizontal asymptote at y equals 0 on the original graph is going to go up to y is equal to 3. So I'm going to sketch that in here. This is the horizontal line that the graph approaches. So that is my horizontal asymptote is at y is equal to 3. Well, what about the vertical asymptote? On the graph of 1 over x, the red graph, the vertical asymptote is at x is equal to 0. And if we move that thing up 3 places, it does not change its location. It still is the case that x equals 0 is going to be the vertical asymptote of the blue graph as well. So my vertical asymptote is at x is equal to 0. So what this means is, if you know where the asymptotes are located on a graph of 1 over x, then adding 3 to it, it's very easy to see where these have to be located as well. This one went up 3 places, but this one did not change. So same idea for question 2. I have the graph of 1 over x, which is located here in red. And the new graph is 1 over x minus 3 plus 1. By using transformations, I know what this is going to do to the graph of 1 over x. It's going to go right 3 places, so that would be my first step. And my second step is it's going to go up 1 place. So what does this mean about the horizontal asymptote and the vertical asymptote? Well, the horizontal asymptote starts at y equals 0 on the graph of 1 over x, and then the first step is to move this thing to the right 3 places, but that does not change a horizontal line. Now the second step takes that horizontal line and it goes up 1 place to y is equal to 1. So if I sketch this in here, y equals 1 is going to be the location of the horizontal asymptote. All right, well, what about the vertical asymptote? If you start on the graph of 1 over x, it's at x is equal to 0. The first step is to move this thing 3 places to the right. So now it appears over here. If we then shift this up 1 place, that does not change its location. So I know that x equals 3 is going to be the location of the vertical asymptote. So just by using some transformations, you can figure out where a horizontal and vertical asymptote are located on your graph. That's all I'm looking for these 2 examples, and the remaining ones will also throw in the idea of intercepts as well. All right, so for this function, again, you could start by just plugging this into your graphing calculator, and you should see something that looks like this. I want to find the location of the asymptotes and the intercepts. So I'll say, where's the horizontal asymptote and the vertical asymptote? Where is the X-intercept and where is the Y-intercept? Again, there should be some connection between the way this equation is written and where these things appear. So to start with, I see that if I maybe look at the X-intercept first, that's located right here. I'm going to go ahead and highlight that. I can actually see on the graph that that has a location of -4 for x and 0 for y. Now the reason this works is because if you look at the numerator of your fraction and you put -4 in place of x, it makes the numerator 0, and therefore the entire fraction is going to be equal to 0. Finding your intercept amounts to determining where the numerator is 0. The only spot where that happens is -4, and that's why we get this answer. All right, what about the y-intercept, which is located right here? I can see that it's located at 0, -2. All right, where this comes from is if you were to take your function and you put 0 in place of all of the x's. So if you do that, these 2 things cancel, and you're left with 4 divided by -2. And if you simplify that, you do in fact get -2 for y. So written as a point, this is 0, -2. And it does match up with this spot. So the takeaway is, for your x-intercept, that's where the numerator is 0. But for the y-intercept, it's going to be the ratio of the two numbers that appear at the end of your equation. 0 for the x value, and then -2 for the y value. All right, what about the vertical asymptote? I can see that as well. It looks like it's around x is equal to 2. So no surprise here that, well, that's the number that makes the denominator equal 0. So there's the connection between the two of those things. If your denominator is 0, we've seen that that seems to cause a vertical asymptote. And for a horizontal asymptote, as we discussed in class, that's going to be the ratio of the numbers in front of your x terms, and they're both a 1 and a 1, so your horizontal asymptote is y is equal to 1. And that seems to match up with the graph as well. So if I actually sketch in those asymptotes, maybe I'd have to go a little bit further out here to see it approach 1, but these are the 4 things we're looking for on this graph. So just to recap, an x-intercept was where the numerator was 0, but a vertical asymptote is where the denominator is 0. Knowing where those factors are 0 are important. The other 2 things were the y-intercept, which is the ratio of the two numbers at the end. It gave us this point, whereas the ratio of the two numbers in the front of the function, that gave us the horizontal asymptote. All right, for my next function, x minus 3 divided by x plus 5, I expanded my viewing window a little bit, going from -20 to +20 for my x-min and x-max. But let's see if those connections still hold true for this function, where I'm looking for a horizontal asymptote, vertical asymptote, an x-intercept, and a y-intercept. I should have an idea of where each of those things come from just by looking at this function. So to start with, we could pick any of these that we want. I see there's a vertical asymptote, and it appears to be centered about x is equal to -5. But that makes sense. That is the number that makes the denominator equal to 0. You put a -5 here, you would divide by 0. It must be that x equals -5 is the location of the vertical asymptote. So I'm just going to go ahead and draw that in here. All right, I see there is an x-intercept, which is located right about here. That's at x is equal to 3, but that makes sense. If you put 3 in place of this x, you create a 0 in the numerator. So it must be that the x-intercept is at 3, 0. These two values came from where the numerator is 0 and the denominator is 0. Everything else comes from a ratio of two terms. For example, the horizontal asymptote. I know it's going to be the ratio of the numbers in front of the x's. They're both 1. I can go ahead and put those in here. That's 1 over 1. But that means your horizontal asymptote is y is equal to 1. So the graph must approach this horizontal line. And that seems to be the case. And then the last thing is, well, here's the y-intercept. It doesn't fall perfectly on an integer. It's something between 0 and -1. And it would make sense that that's going to be 0 for x. And if I look at the ratio of these two numbers, it's -3 over 5. So here are both the intercepts and asymptotes on this equation, and they came directly from examining this function. All right, same idea here. I'm looking for horizontal asymptote, vertical asymptote, an x-intercept, and a y-intercept. All right, I can kind of see where the vertical asymptote is located, but I don't think my y, min, and max are large enough to really see it perfectly. It seems to be around maybe +4 or +5. But I see up here that, well, if x is equal to 4, that creates division by 0. It must be that 4 is the value of the vertical asymptote. So I'll just go ahead and sketch this in. There we go. X equals 4. Okay, that makes sense. All right, my x-intercept, I can see that it's located right here, something between -2 and -3. But if I look at the numerator, the place where this is equal to 0 is going to be -5/2, which is -2.5. So I know that my x-intercept is -2.5, 0. All right, just to be a little bit careful, where this came from is, you can take the numerator, 2x plus 5, set it equal to 0, And this becomes a pretty simple equation to solve. It's where is 2x is equal to negative 5. Dividing both sides by 2 gives me x is negative 5 halves, or negative 2.5. So again, this spot came from where the numerator was 0. This vertical line came from where the denominator was 0. All right, two other things. The y-intercept should be the ratio of these last two terms. So that should be 0, comma, in this case, negative 5/4. And that seems to make sense. That's right here. It's a little bit less than negative 1, so that matches up. But this time, the horizontal asymptote, we don't get 1 because the ratio of the numbers in front of the x's are actually 2/1. This means the horizontal asymptote is 2. And that seems to be a little bit more accurate than 1, right? I mean, it can't be 1 since the left side of the graph seems to go past that, but it definitely goes up towards 2, and then on this side down towards 2. And these are the 4 features of this graph. Here we have y is equal to 9x divided by 3x plus 6. Looking for the same things on the graph. A horizontal asymptote, vertical asymptote, and as well as the x and y intercepts if they exist. Let's see. Well, I can start with anything I'd like. Maybe the X-Intercept. I can see that one pretty easily. That's right here. So this is where the numerator is equal to 0, and clearly 9x equals 0 at x equals 0. So your X-Intercept is 0, comma 0. The reason being, if you take the numerator and set it equal to 0, clearly x equals 0 is the solution. But actually, the y-intercept is also the point 0, 0. That's on both the x and the y-axis. And if you look to the function, you could put a plus 0 at the very end in the numerator. So this makes sense too. If you look at the ratio of the two numbers at the end, it's 0/6, which is simply 0. So this works, but so does that. All right, what about the, I guess, vertical asymptote? It appears to be around maybe -2. If I look at the denominator is 3x plus 6, and we're asking the question of where is this equal to 0? Well, if you subtract 6 from both sides, you get 3x is equal to -6, dividing both sides by 3 gives you the answer that x is equal to -2. So that's the location of the vertical asymptote. That's where the denominator is 0. So we can put that in here. And then one last thing would be the horizontal asymptote. All right, this is coming from the ratio of the numbers in front of the x's. So that's 9/3, and that simplifies to just 3/1. So 3 is going to be the horizontal asymptote. And that's what it looks like in my graph. It looks like y equals 3 is where the graph becomes horizontal as we head towards both positive and negative infinity. So here is the complete graph of this function. All right, so looking for the asymptotes and intercepts. All right, well, the vertical asymptote looks pretty clear that it is at x is equal to 0. And that makes sense with our equation. Because the denominator is equal to 2x, the place where that is 0 is definitely x is equal to 0, so that works. And the X-Intercept, kind of hard to see, but it does look to be around -7, which definitely matches up with our equation that -7, 0. That is precisely where the numerator is 0, so that works. The horizontal asymptote, if we're following the rules that we have, it's going to be the ratio of the numbers in front of our x's, which is a 1 divided by 2, or a half. And that looks pretty reasonable too. This time it's definitely not going to be 1 or 2 or some integer, but it appears to be something, roughly halfway in between. So that matches up with the graph as well. And the last thing is, well, what about the y-intercept? That's where the graph crosses the y-axis. Now, the ratio of the two numbers at the end of this function, you have to be a little bit careful. You have to put plus 0 at the end, and the ratio would have to be 7/0. And if you try to get that value, you can't divide by 0. That would give you an error message. Said another way, this thing has no y-intercept. That makes sense. The graph can't cross over this vertical asymptote, meaning there is no point at x equals 0. You put 0 into the x's in this function, you would get an error message. So it is possible that you might not have some of these things. And that is it for this graph. Last one here for our basic rational functions. This one's going to be a little bit different. We looked at a graph of 1 over x, but what if you had a graph of 1 over x squared? So there's really not much to say about this one except for there is a horizontal asymptote, which you can clearly see by looking at the graph. That's going to be y is equal to 0. And there's also a vertical asymptote, which is at x equals 0. Can see that as well. So we'll put both of these things up here. There is no x or y intercept. It can't cross over either of these asymptotes in this case. So I'll say there are no intercepts. So I'll say no x-intercept, there's no y-intercept. And in a lot of ways, this graph, it's a lot like just 1 over x. 1 over x had a piece over here, but on the negative side, it was below the axis. Here, if you're squaring all of your y values, the ones that have negative y values become positive again. The big difference is, if you have an exponent of 2 at an asymptote, it means the graph would have to go up on both sides instead of up on one side and down on the other. So you can look at this one in your graphing calculator. Clearly there are no intercepts, although these are the two asymptotes, a lot like the graph of just 1 over x. All right, let's sketch a graph of this rational function. This one's much more complicated than the ones we've looked at, but we're going to use the same ideas here, where to keep things simpler, I left an unscaled x and y axis. I'm going to try to locate all of the intercepts and asymptotes, plot them on here, and then sketch the graph in around it. So we're really looking for the same things. I'd like to know, is there a horizontal asymptote, a vertical asymptote, as well as any x or y intercepts. So an x-intercept and a y-intercept. All right, so for this one here, if we start with the vertical asymptote or an x-intercept, that's coming from where the numerator or the denominator is equal to 0. And currently, it's kind of difficult to see where those are. But what I'm going to do is factor both the numerator and the denominator. If I factor the numerator, I get x1 and x plus 3. And the denominator is going to be x plus 7, x minus 5. The reason I'm factoring it is because wherever the numerator is 0 is going to be an x-intercept, wherever the denominator is 0 is going to be a vertical asymptote. If I start with the vertical asymptotes, I know one has to be at -7, and another is at +5. So let's sketch those in. So I have a vertical asymptote at x is equal to -7, and also one at 1, 2, 3, 4, 5. What about x-intercepts? Well, that's wherever the numerator is 0, so there's got to be one at -3, 0, but also 1, 0. So there's one here and here. All right, the y-intercept is going to be the ratio of the two numbers at the very end of this function, which is -3 over -35. That simplifies to a +3 over 35. That's some small number that's close to 0. I'll try to indicate that by putting this here. And there's one last piece, that last piece being, what is the horizontal asymptote? We're not going to use the ratio of the numbers in front of the x's. We're going to have to look to the highest powered x terms. Both of those have a 1 and a 1. This means the ratio of the two numbers is the horizontal asymptote, which is y is equal to 1. And I'll put that right about here. All right. If I want to get a complete sketch of my equation, I know my graph has to go through these intercepts and approach the asymptotes. I know there's no intercept here or here, meaning the graph has to be above, like this, on both sides. This would be a good time to now compare this to what you see in your graphing calculator. The function I get looks like this. All right, so here is a decent sketch of the graph. There is one last thing I'd like to check in this example is, does the graph cross over the horizontal asymptote? And the way to check this is, take your equation, set it equal to 1, and solve for x. Let's do that. So I'll say, does this cross y equals 1? I'll take my equation, set it equal to 1. I will cross multiply this piece to the other side, which gets rid of this fraction and leaves this side on the right. So that is, where is x squared plus 2x minus 3 equal to x squared plus 2x minus 35? Any solution to this equation is where the graph crosses over the horizontal asymptote. I know I can just cancel x squared from both sides, but actually you can also cancel 2x, and we're left with negative 3 is equal to negative 35. That is a false statement. So the good news is that the graph never equals y equals 1. So this graph is always above y equals 1 on this side, and the same thing over here. It's always above y is equal to 1. It gets really, really, really close to that asymptote, but it never equals it, and here's a complete sketch of the graph. All right, same idea. I'd like to figure out where are the asymptotes and intercepts of this equation. I personally like to start with the vertical asymptote and the x-intercepts because that's where my factors of this function are 0 in the numerator and denominator. So I'm going to start actually by factoring this equation. X squared minus 9 is x minus 3 times x plus 3. In the denominator, I have x minus 5 times x plus 5. Knowing this information, the denominator is equal to 0 at both negative 5 and positive 5. That has got to be the vertical asymptotes. And the x-intercepts would have to be at negative 3 and 3 for x. Let's sketch this information in there. So negative 1, 2, 3, 4, 5. That's the location of one of the vertical asymptotes, and 1, 2, 3, 4, positive 5. That's the other. I have an x-intercept at negative and positive 3. And let's see, what else? Horizontal asymptote is going to be the ratio of the numbers in front of the highest powered x term. So that's going to be a 1 over 1, or just simply 1. So I can draw that in there like this. And my x-intercept is going to be the ratio of the two numbers at the end. They're both negative. This means this simplifies to 0 for x and positive 9 over 25 for y. Again, it's some positive number. Maybe it's like right about there. If I compare this thing on my graphing calculator, I know it'll look a lot like the previous graph where it's got to approach the asymptotes as well as go through these points. And it has to be that the equation's up here on both sides. Before I sketch this one, I'm going to check this idea of, does this graph cross over this horizontal line? So again, does the graph cross y is equal to 1? I think the answer is going to be no, but let's just double check. When is x squared minus 9 divided by x squared minus 25 equal to 1? If I cross multiply, I get x squared minus 9 is equal to x squared minus 25. This simplifies even easier than the last one. The x squareds cancel, and I get negative 9 is equal to negative 25, a false statement. So this does not at any point cross over y is equal to 1. I know what my entire graph has to look like. It's approaching the asymptotes, going through the intercepts, and therefore my graph has to be up here and up here. And that's an accurate sketch of the graph. All right, to sketch this function, same thing. Look for the horizontal and vertical asymptotes as well as any intercepts. All right, this equation is different in that there is no x squared in the numerator, but there is one in the denominator. So that might change things a little bit in this example. But I'm going to start the same way where I want to figure out the vertical asymptote and the x-intercept. Therefore, I have to factor my equation. If I do that, well, there is nothing to factor in the numerator. It's simply just x plus 1, but my denominator is x, let's see what we get here. For 36, I guess that's x minus 9 and x plus 4. The sum is -5. The product is -36. Excellent. So the vertical asymptotes have to be at -4 and +9. But this one actually has only one x-intercept, and that's at -1 for x because you get 0 back for y. Let's plot all these things. -1, 2, 3, -4. That's one of the vertical asymptotes, as well as, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the other. And then -1, 0 is the only x-intercept. Let's find the y-intercept. That's going to be the ratio of the numbers at the end. This time it's a -1 over 36. So that would be 0 for x and -1 over 36 for y. -1 over 36 is really close to 0. It might not show up very well in your graphing calculator, but I'll draw that as being right here. And the horizontal asymptote is going to be different in that you have to compare similar powers of x, and there are 0x squared in the numerator. So as a matter of fact, I'm just going to take this and put in 0x squared to the top of this equation. That way I can compare this number divided by this one. That is 0 divided by 1, or simply just y is equal to 0. It turns out that y equals 0 is going to be the horizontal asymptote of this function. If I now sketch in my equation, I know the graph has to go through these two intercepts and approach both of those asymptotes. So I'm going to draw what's happening in the middle. The graph has got to look like this. And then for the ends of my graph, I have to be careful about, well, is the graph down here or is the graph up here? I'm just going to plug some points in my graphing calculator to see which it is. All right, I can see that the graph is below on this side, getting closer and closer to y equals 0, and then it is above on this side over here, like this. I think the final question again is, does this graph cross over the horizontal asymptote of y equals 0? And actually, the answer to this question is yes. You can see it happens right here. The graph goes over y is equal to 0. This is going to be the only time that this happens, but let's just double check that. So, does this cross y is equal to 0? The answer is definitely yes. I just want to make sure it never happens again. So I'm going to take my equation, which is x plus 1 divided by x squared minus 5x minus 36. I'm going to set it equal to 0 this time instead of 1. When I multiply this denominator to the other side of the equation, this whole thing times 0 is just 0. This cancels nicely. It's just x plus 1 is equal to 0. And I know that happens at -1. Now, we knew that ahead of time. We can see it right here. But the nice thing is, I know this never happens again. That means the graph here is always below y equals 0 on this side and always above y equals 0 on this side. And here's a complete picture of this graph. All right, so for this equation, again, horizontal asymptote, vertical asymptotes, any intercepts, meaning we will have to factor this equation. Let's see, if I look at this, all right, factors as x minus 3 times x minus 4 divided by x plus 5 and then x plus 6. Therefore, if I have a vertical asymptote, well, I have to have two. One at x is equal to -5 and also x is equal to -6. My x-intercepts would have to be at 3 and also 4 for x. My y-intercept is going to be the ratio of the two numbers at the end, which is 12 and 30. All right, so let's see, that would be 0. If I cancel a factor of 2, that is 6/15. Could also cancel, I guess, a factor of 3, so that's 2/5. And my horizontal asymptote is going to be the ratio of the numbers from the x squared terms, that's y is equal to 1. So if we put all this in here, that's negative 1, 2, 3, 4, both 5 and 6 are vertical asymptotes. My intercepts are at 3 and 4. So let's see, 1, 2, 3, and 4. So that's here and here. My y-intercept, it's a little less than half, so that's about here. And y equals 1 is the horizontal asymptote. All right, does this cross the horizontal asymptote? So does this cross y is equal to 1? I can kind of see that that's going to happen. If I'm going through these points, it's definitely going to go over the line y equals 1, but maybe I want to figure that out exactly. So again, I'm taking my original equation. I'm going to set it equal to 1. But we saw that essentially means we cross multiply this thing to this side, the x squareds will cancel, and I'm solving the linear equation where these two pieces are equal to each other. This whole thing amounts to solving, let's see, negative 7 plus 12 is equal to 11x plus 30. So if I subtract 30 from both sides, as well as add 7x, my equation becomes 18x is equal to negative 18, and therefore after dividing both sides by negative 18, negative 1 is where this thing actually equals the horizontal asymptote, which is right here. Okay, so now I'm going to go to my graphing calculator to see what this graph looks like, and it's not a very good picture, which means, I'll have to kind of approach this, maybe figure out what's happening in here, and then I see there's a little piece up here, but I'm going to exaggerate it by drawing it going down to this equation. So here is essentially what my picture looks like. I know this comes down, goes through these points, crosses here for a little bit before coming back up and going up to y is equal to 1. And over here on the left side, from negative 6 going in this direction, I know the graph is going to be up here and it never crosses over this line. So again, this is just like a rough approximation of what's going on. I know the graph is up here and it never crosses. But what's happening between negative 6 and negative 5? Is their graph going to be up here or is it going to be down here? I'm thinking the graph is going to be down here, and it could be pretty far. So again, I don't have the y-axis scaled. I'm just going to draw that I think the graph looks like something like this down here. I'm even going to go to my table to check this. I'm going to type in negative 5.5. Yeah, I'm getting a very, let's see, negative 323 as my value. So I know the graph, it's down here somewhere. It looks like this. So this is messy, but here's kind of a description of what my graph is doing. And that is it for this example. So let's begin by factoring this equation. In the numerator, let's see, we're going to have x plus 4 and x minus 3. In the denominator, we have x minus 8 and x plus 7. So going through our list of things, maybe changing the order up a little bit. So we could look at a vertical asymptote and X-intercepts first, if you like going in this order, followed by the Y-intercept and then a horizontal asymptote. Vertical asymptotes are going to be located at x is equal to positive 8 and x is equal to negative 7. My X-intercepts are negative 4, 0, and 3, 0. My Y-intercept is negative 12 over 56, so it's a positive 12 over 56. Maybe if you want a better fraction for that, that reduces to 3/14. So, something pretty small. And then, okay, here again we have that the horizontal asymptote of y is equal to 1. And might as well just go ahead and say, does this thing cross y is equal to 1 at some point? Again, that's just taking my equation and setting it equal to 1. As we saw in the last example, that will amount to saying x minus 12 is equal to negative x minus 56. So if you set the equation equal 1, cross multiply and cancel the x squares, it will reduce to this equation. If I add x and 12 to both sides, I get 2x is equal to negative 44. Dividing both sides by 2 gives me negative 22. All right, so it's going to be some value that's way over here, so I'll have to be clever in how I mark that just as a reference. But let's graph this equation. So I'm looking at it in my graphing calculator, much better picture than the last one. Okay, so filling in everything that we know. Let's see. 1, 2, 3, 4, 5, 6, negative 7 is one of the vertical asymptotes. And 1, 2, 3, 4, 5, 6, 7, 8 is the other. Let's see. My intercepts, again, are at negative 4 and positive 3 with 3/14 where it crosses over the y-axis. I'll put in y is equal to 1. It's my horizontal asymptote. I'm just going to make a note that way over here, this is going to be over at negative 22, so definitely not drawn to scale, but at least so I can have something to look at on my picture. I know the graph equals 1 here and should cross over the axis and either stay on one side or the other. If I sketch my graph and around it, I get this. And over here, goes to this point, crosses over before coming back up. And here's the picture of my graph. All right, so factoring this equation, let's see, in the numerator, we have really similar to the last one. So that's x minus 4x plus 3 this time. So that's flipped around with the positive and the negative. And then we have, okay, that's going to be x minus 6 and x plus 1. So that should be enough information, again, to get the vertical asymptote, X-Intercepts, Y-Intercept, and horizontal asymptote. The vertical asymptotes are at 6 and negative 1. The X-Intercepts are at negative 3, 0, as well as 4, 0. Y-Intercept is negative 12 or negative 6. That's positive 2, so that kind of works out nice this time. 0, 2. And my horizontal asymptote, again, it's equal to 1. And if I graph all this stuff, let's see. I have negative 1 and 1, 2, 3, 4, 5, 6, the location of the two asymptotes. What else? I have negative 3 and positive 4 for the intercepts, as well as y equals 2. And my horizontal asymptote, again, is equal to 1. And if I look at this thing on my graph, pretty easy to see what's going on. So we're going through this point, coming down here, crossing over that point, and then the graph appears up here. So does this cross y equals 1? Again, we have a situation where you can see it pretty easily. It would have to happen somewhere around here between these 2 points. So I'm going to set this equation equal to 1. And again, we've seen that this amounts to solving negative x minus 12 is equal to negative 5x minus 6. And after adding 5x to both sides, as well as 12 to both sides, and dividing both sides by 4 gives me 6 over 4, that's 3 over 2, or 1.5. So at 1.5, or 3 halves, the graph should equal 1. And that's the only place where it happens. So over here, the graph goes up to 1 but never equals it. And then the same thing happens over here. Let's sketch in our graph. Comes down, goes through these points, drops down again. Goes over here like this. And then we have a piece over here. And this is a sketch of the graph. To solve problem 15, we're going to use question 9 that we already have done. So we're using the graph of this function to see where it's greater than 1. All right, I know that this is y is equal to 1, so I'm going to go ahead and label that in my picture. And I want everything that is above it, which refers to this piece and this piece. I also know the graph never actually equals this horizontal line. All right, so I just need to know what is this x value going in this direction and this x value going in this direction. This is x is equal to 5, and this is x is equal to negative 7. So the portion of the graph that we're really referring to here is, I want all of this and this. And the x values that correspond to this are here and here. The answer to this question is everything from negative infinity to negative 7, together with everything from 5 to infinity. So these questions are directly answered by using a graph. All right, for question 16, we're using the graph from problem 10, and I want to know where is this graph lower than y is equal to 0. So we're not using 1 this time, but we're referring to where is it less than or equal to y is 0. So again, let's see here. We're talking about this and including this spot down this way, as well as this spot here. These are the y values where we're less than or equal to 0. The corresponding x values for those points are everything from here to here, as well as everything from here to here. So I just have to know where are the x-intercepts and where are the vertical asymptotes. Well, the vertical asymptote is x is equal to negative 5. The x-intercept is x is equal to negative 3. And this is x is equal to positive 3 to x is equal to positive 5. So again, I'm just looking at the features of the graph to get this. Therefore, my answer to this problem is everything from negative 5 up to and including negative 3. Also, everything from positive 3 up to and not including positive 5. And that's the answer to 16. All right, so here we're using the graph from problem 11. And now I want to know where is the graph above y is equal to 0, which is in fact the horizontal asymptote this time. And I think I'll label in everything that we need to know ahead of time here. So we had that negative 4 was this vertical asymptote, whereas positive 9 was this. And also there's an x-intercept at negative 1. These are going to be the negative 1. These are going to be the relevant points for answering this problem. So where's the graph greater than 0? That has to be this portion of the graph as well as this portion of the graph. And therefore, my answer to this problem is negative 4 to negative 1, not including either. There's no equal sign on the inequality. And also everything from 9 to positive infinity. So here we're using the graph from problem 12, and I want to know where is the graph below y is equal to 1. So labeling all of the correct places, we have the vertical asymptotes were at negative 6 and negative 5. This thing crossed over the horizontal asymptote at negative 1. So we want every spot that this graph is below 1. So that's definitely this part of the graph here. It equals 1 at this spot, and it's below 1 as we head in this direction. Corresponding x values are this stuff, and everything's starting here and going in this direction. So the answer is everything from negative 6 to negative 5, not including either of those points, but we are going to include negative 1 and go up to positive infinity. All right, here we're using the graph from problem 13, and we have two things happening in this inequality. We want to be not only less than or equal to 1, we would also like to be greater than, actually I think it was just greater than 0, so I'm going to get rid of this equal sign here, just strictly greater than 0. I'm looking for all the stuff trapped in this little region. So let's see what we have if we're stuck between 1 but also 0. All right, I see that there's this part of the graph, but there's also some stuff over here. I mean, it goes forever in this direction, so these are the y values we're talking about. The relevant corresponding x values, the x is equal to -4 and +3, but also this one, this -22 that we got in the problem as well. All right, so that means on the x-axis, I'm going from here to here, but also from -22 going in that direction forever. And I just have to be careful about what values I am or am not including. So starting with this piece over here, since there's an equal sign on the 1, I actually would like to include this -22. So the first part of my answer is -infinity to -22. And then I would like to go from -4 to +3. But I'm not going to include either of those values because they actually equal 0 at those two numbers. And this is my answer. And lastly, here we have for question 20, using the graph of the problem from -14. All right, where are we greater than 1? Labeling the relevant points on the graph. Here is y is equal to 1. We figured out that this spot here was 1.5 for x. I think I'll also need to write down that the vertical asymptotes were at -1, but also +6. And with this information, being greater than 1 is referring to this portion of the graph here. And I know it never equals 1 over here, so I don't have to worry about including stuff down here. This portion of the graph is always above 1, so I do want to include this entire portion of the graph. So I want all this stuff too, which means I want the x values from here to here, as well as from this spot going towards +infinity. My answer is everything from -1 up to and not including 1.5 together with everything from 6 to +infinity. All right, let's find the vertical asymptotes of this graph. I'm expecting, just by the way it's written, that the vertical asymptote is going to be at x equals 2. So if I plug this into my graphing calculator, again, you got to be careful to write this as parentheses 2x minus 4 divided by x minus 2. And I do not see a vertical asymptote at 2. In fact, if I graph this thing, it just looks like a horizontal line at 2. So, here's 1, 2, and the graph I see goes across just like this. Clearly no vertical asymptote at 1, 2. So what's going on? Anytime that you divide by 0, that can't be a point on the graph. So if I check my table, I check 2 and I get an error message, so that's okay. So what's going on at this spot? Let's examine the graph a little bit more carefully. So we have y is equal to, well, I see you can factor out 2 from the numerator. And this graph is really 2 times x minus 2 over x minus 2. There's this common factor of x minus 2. When you cancel it, it leaves you with 2. This is exactly why we're getting this horizontal line. But I can see from the table that the graph does not exist at this point. That means there's a hole in the graph. So it is possible if the denominator is 0, you might not have a vertical asymptote. The other possibility is there's a hole. Anytime that you cancel a factor between the numerator and the denominator, at that x value, there will not be a vertical asymptote as long as it completely cancels. Instead, there's going to be a hole in the graph. So let's be careful in this example too. So I'm going to start by factoring it. If I factor the numerator, we get x minus 5 and x minus 3. In the denominator, we get x minus 3x plus 2. Oh, well, here we have another situation where this factor can cancel with this factor, And we're actually left with the equation x minus 5 over x plus 2. So I'm not expecting a vertical asymptote at 3. In fact, the only vertical asymptote I expect is going to be at x is equal to negative 2, but not at x is equal to 3. Instead, at 3, there should be some type of hole in the graph. All right, so I'm going to look at this thing in my graphing calculator, and I do, in fact, see a vertical asymptote at negative 2. But I do not see one at 3. So let's see. If I go to sketch this thing, I know there's a horizontal asymptote at 1, and my graph should look like this. I know there's an X-intercept at 1, 2, 3, 4, 5, and there's also a Y-intercept at negative 15 over 6. So that's a little bit less than 2. So here's my graph. But the only thing I'm going to add in here is that at 3, there's a hole in the graph. It doesn't exist there. When I go to my table and type in 3, it gives me an error message. So the takeaway here is, if you completely cancel a factor, what happens is there's a hole instead of a vertical asymptote.